D'accord. Et le IR, là, au départ, IR point, c'est quoi?
C'est madame, ouais,
Ah, d'accord, d'accord. Donc, c'est Riri, Fitri, Sari. OK, très
ouais,
bien. Le IR veut rien dire. OK, très bien, très bien.
ouais, c'est madame, ouais.
Bon, je suppose que elle parle pas français, hein, c'est ça, hein?
Non, en anglais,
Bonjour.
ouais.
Bonjour.
Bonjour.
Hello, hello.
Bonjour.
Hello.
Il nous manque Hassan.
Je vous envoie le lien pour, si vous voulez, une salle à part pour la délibération.
On enlève la caméra comme ça, on va lui conserver la bande passante à la collègue.
Bonne idée.
Oui, salut.
Salut, dis-moi, c'est ce matin la soutenance de
Oui,
Rémi?
c'est ce matin, c'est maintenant, on t'attend.
Mais justement, mais le lien, je ne trouve aucune trace du lien.
Ah,
Est-ce que tu peux me le renvoyer?
ouais, je te renvoie.
Ah, le lien, attends, tu me l'as envoyé, attends. Non, tu as envoyé le lien de
Le lien pour la délibération, et l'autre, tu as dû le recevoir, mais je te le renvoie, hein.
Par qui je l'avais reçu? Je me souviens pas.
Madame Sari, tu l'as reçu.
Ah, c'est ça, je l'ai envoyé. Ok, désolé. C'est pour ça que je commençais à me dire. Ça, l'expositeur contient ça. Ah, je rêve de trop. Ah, si tu me l'envoies, ça serait plus
Ouais,
rapide.
je t'envoie.
C'est bon. Est-ce que j'ai quelque chose?
Là, je t'ai envoyé.
Attends, ok. C'est dans les tuyaux, il est 10 heures pile. Je vais pas vous ralentir.
Non, tu as dû recevoir le lien.
Ouais, justement le temps.
Ben, bonjour à
Recording in
tous.
progress.
Donc, tu m'as dit qu'elle parlait pas français, hein, c'est ça, hein?
Bon, ouais, enfin, en anglais. Ouais.
D'accord, très bien, très bien. Eh ben, okay, so good morning. We are here today for the presentation of your research work of Mrs. Riri Fitri Sari. Okay, and the jury is composed of 3 reviewers. So, Professor Hassan Fouchal from University of France, Champagne-Ardenne. Je vais quand même mettre vous mettez la caméra juste pour la présentation, s'il vous plaît. Hassan, très bien. The second reviewer is Professor Ahmed Naitsidi Mo from University of Jean Monnet Saint-Étienne. Il est là, très bien. Hello. The third reviewer is Professor Abdelmajid Bouabdallah from University of Technology of Compiègne. Abdelmajid. Hi, Abdelmajid. We have also Pascal Lawrence, who is your HDR supervisor. Pascal. Hi, Pascal. And Linda Mogdad. So, Linda Mogdad from University of Paris Créteil, and I am the president of this committee. So, please, you have 45 minutes for your presentation. Okay?
Thank you so much, Professor Linda Mogdad from Paris. Good afternoon, everyone. It's 3 o'clock here in Indonesia. Greetings, and thank you so much for your presence today in my HDR event presentation. And I'm very delightful to present the work today. Thank you very much for the opportunity, Professor Pascal Lawrence, for providing the time for me to explain my HDR report. I would like to thank Professor Linda Mogdad, Professor Pascal Lawrence, Professor Hassel Fouchal, and Professor Ahmed Naid Sidi Mohammed from France, and Professor Abdelmajid Bu Abdallah. My name is Riri Fitri Sari from the University of Indonesia, and I'm going to talk about our work in the last 15 years on blockchain for sustainable development, the design, deployment, and evaluation of ethical digital infrastructure aligned with SDGs. I would like to thank my team at the University of Indonesia, who's done a lot of work during this last 15 years. And today we are going to present them under one umbrella of, previously we are called IoT Research Group, and now it's IoT Plus Research Group, and then it becomes now X-Intellitech Technology Research Group, because it's intelligent technology that we are putting together. And also now in the last year, we've been talking about responsible AI and agentic AI lately. But when I talk about this, it was not that yet. So in the last year, we have been talking about agentic AI also. And previously, we are talking about blockchain, machine learning, computing, and I've been working a lot also with 4 students together, working with Professor Pascal Lawrence during our collaboration for PhD students, double degree in Indonesia and in France. So this is my profile. I did my PhD in Leeds in 2004. I completed them, and also our research in computer networks, distributed and network computing, blockchain architecture, and data structures. Today I'm going to talk a lot about this.
With your slide, because we see only slide 54. We don't see the slide.
Oh, sorry. Okay, I will again. I will start showing again to make sure that it's going to be the right one. Sorry. Can you see slide number 3 now here, Professor Pascal? Is it okay now?
And now it's okay.
Okay, right. Thank you so much. So, and I've done a lot of publications with my students, and also I've been working on. I'm talking a lot about Sustainable Development Goals (SDGs) because I've been founded. I'm the founder of UI Green Metric World University Ranking, and last week in Leicester, we launched what is called Responsible AI University Rankings under Redan Charter. It's called. And then it is we have been working on a lot on patents, supervising 24 PhD students, and at the moment I have 11 ongoing PhD students and master students and undergraduate, of course. Okay, let me start with the introduction of our work and why I choose blockchain and sustainable development goals. I'm going to talk about the theoretical framework, the blockchain consensus mechanism that we have been building in our research group, and the implementation, real-world development of blockchain, and also the contribution of analysis for the SDGs mapping, and also a conclusion and future directions. Ladies and gentlemen, dear jury, okay, I'm going to talk about my motivation, our motivation for talking this. 2 decades of digital transformation across governance, finance, health, and energy has been put into some work together with blockchain, because we know that it is going to, it has matured and transformed our life. We know that cryptocurrency has been rising, and however, since last year, this year, it's going down, but it is an opportunity to provide democratic way for the future implementation of technology also. So for the purpose of transparency, immutability of data, and different perspective to provide a safe and secure environment in the future. The second topic about SDGs, because in the last since 2015, United Nations offer a unifying framework for inclusive and sustainable innovation. But actually, the UI Green Metric has been started 5 years before, which is a ranking for all universities. At the moment, more than 1,800 universities worldwide using that as a benchmark to improve the infrastructure in their university. So we are thinking about the future, because responsible AI is number one and is the most important thing that we have to look into to make sure that we still can ensure that human in the loop and human computer interaction come up to the aim of the direction that we would like to achieve. There are strategic alignment of ICT with SDGs outcome in this research, and these are the SDGs that we are tackling: SDGs number 9, SDGs number 16, 7, and 13 for industry and innovation, clean energy, climate actions, and also, of course, collaboration and strong institution to achieve this and fair and just environment in the future. So the problem statement and the research group that we would like to attack previously was that high energy consumption from traditional consensus mechanisms such as proof of work being used in Bitcoin. And we have problems such as the lack of adaptive, lightweight, and context-aware consensus protocol, which enable us to use IoT in the future based on blockchain technology, and also minimal attention to ethical design and SDGs integration, and also insufficient interoperability with real-world infrastructure and IoT at the moment. So these are some work projects that we did last time on waste management, renewable energy trading, electronic medical record system, payroll and attendance, news verification, using different key technologies, building information modeling, construction, transparency, game for cheating detection, and proof of intelligent reputation consensus mechanism using AI for bidirectional long short-term memory, and also smart contracts and energy-aware proof of authority consensus mechanism, in which is using blockchain energy-aware mechanism in this wireless sensor network. So this is the relevant SDGs map into this. So the research objective is that we develop a coherent blockchain trajectory from simulation using different simulator of blockchain, starting from the one that we use using Python in NS2 in different platform, Aura and other blockchain platform, and also we created some consensus design for to be used into improving the blockchain. We aiming to address major blockchain limitation in energy efficiency, trust management, and real-time responsiveness. And we approach this with different approach, and eventually it has been published in some Q1 peer-reviewed journals. And also our study demonstrates that blockchain applicability in energy trading, e-waste management, payroll, security, healthcare, news verification, and game authentication was good in implementing to show that a blockchain can be used as the replacement of the mechanisms such as the database, the manual database. It advances blockchain architecture for constrained environment through lightweight and trust-aware validation mechanism. Our research also embeds SDGs-oriented metrics into system design to ensure sustainability and community-centered innovation. And we know that this blockchain is a decentralized and immutable ledger secured through cryptographic linkage between blocks. And back in 2008, Bitcoin model was introduced by the anonymous person called Nakamoto. And it has changed the way we look into how we can eliminate the immediate intermediary within the system, so that it is more efficient. And also blockchain security that we know previously relies on public key cryptography and immutable transaction records, but we know that this secure mechanism provided by blockchain is something that we need in the future. Also at the moment, it has been used in many applications. So if we can see this architecture and components, it consists of interconnected layers supporting security, decentralization, and transparency. The data layer itself secures transaction using cryptographic hashes and Merkle tree structure. And also the network layer enables decentralized peer-to-peer communication and ledger synchronization. And the consensus layer here ensure that agreement on ledger validity through distributed validation protocol. And incentive layer motivates network participation through rewards and transaction fee. And the contract layer enables automated execution through blockchain-based smart contracts. And the application layer connects blockchain infrastructure with real-world decentralized services. So these are the classification of blockchain system. Previously, we started with the previously we have blockchain types such as public blockchain, which is open to everyone with permissionless. Without any permission, it is fully decentralized, transparent, and community-driven. For example, in cryptocurrencies such as Bitcoin and Ethereum that it has been widely used now, we are using this public blockchain. The advantage is that it has a high transparency, censorship resistance, and however, the limitation is scalability issues and high energy consumption under proof of work consensus. We also have private blockchains such as Ethereum, which is controlled by one organization, need permission, centralized governance, and restricted access. It has been used for enterprise asset and asset tracking, inventory management, and it is fast and efficient. Also, we have consortium blockchain managed by multiple organizations and hybrid blockchain combination of public and private access here, commonly used in smart cities, public-private partnership, and government registries. This is flexible, scalable, and interoperable. So looking into some problems, all of the problems that we would like to improve in our world now is to balance ESG, environmental, economic, and social dimension of our world. We focus on ensuring that the needs of the needs of the future generation should not be harmed by the current generation. We have to leave this earth in a good condition. And that is why we look into different technologies to ensure about this. And emerging technologies such as AI, blockchain, and IoT support transparency, efficiency, and innovation. We also ensure that the currently happening digital transformation also introduce challenges. For example, now when we are using AI for everything, 58% of world population now are using AI for their working, for living, and many things, even for doing and negligible things, but it requires a lot of energy consumption, and we have to think about this. And also the electronic waste, and we have to bear that digital inequality is there in our world, and we have to face this. Sustainability is now a key benchmark for evaluating technology, governance, and development strategies. And that is why this work related to blockchain technology relevant to this is the currently we are talking about relevant SDGs 3, 4, 6, 7, 9, 10, 11, 12, 13, 15, and 16. So this is our research trajectory. Actually, we previously worked a lot with simulator development, then also development of blockchain platform for IoT. Previously, last semester, we also worked on development of IoT using Raspberry and ESP multi-controller, and also development of blockchain consensus here to improve the current condition in which we know that the consensus is something that requires to be strengthened and to be robust. So previously we do some survey and analysis simulator, the cryptography simulation and analysis, also consensus algorithm simulation. And therefore, we work and try to tackle multi-sector blockchain implementation one by one. For example, in construction, building information modeling, we use blockchain implementation in BIM. Also for waste management and things like healthcare data system, voting mechanism that is required, and eventually also in social media, as well as ensuring that the future technology such as DAO, decentralized autonomous organization, can be provided to enable a more sustainable and more democratic opportunity for everyone in the world. So, talking about scalable, efficient, and trustworthy blockchain consensus mechanism, actually we have conducted some research. This is the work of my students, PhD student, Fidi, on Merkle state, multi-state Merkle Patricia tree for conventional blockchain system, and also using Bitcoin, knowing that Bitcoin uses UTXO-based model. We try to improve the efficiency using Merkle Patricia tree and account-based architecture. And in this work, the key innovation is that we are talking about the leaf nodes and also this approach ensuring that the optimal linked list containing different information can make it optimum. So also the result is this, the experimental findings in which we can make it faster and performance remains stable after testing on thousands of blockchain blocks. And we are also comparing the conventional Merkle-tree performance with the improvement of blockchain size increase and other things in performance evaluation. So I've been working a lot with performance evaluation of computer network using NS2 and NS3. And previously we work a lot on improving that via simulation. Then this is also another work of my PhD students, proof of intelligent reputation for improving, after we are talking a lot about consensus on proof of work, proof of authority, proof of stake, PBFT, and different new consensus. The previous one always have high energy consumption, and also the centralization of risk in reputation-based systems such as proof of stake and decentralized proof of stake, and also resource manipulation, monopolies by dominant nodes here. And the proposed solution is to introduce proof of intelligent reputation, which is an AI-driven consensus mechanism using BLSTM and Network Entity Reputation Database, NERD, which has a better scalability. Some of this work also conducted by Delphi, my PhD student, and also for machine learning implementation on this blockchain network component and making sure that the mechanism of proof of intelligent reputation works. And this is the result of this is the proposed method for the intelligent node selector mechanism. And we have eventually have selected the class and also proposed the new block and validate the new block here. So knowing that verification and validation for this blockchain node and leader selection mechanism is very important. We work on class-based mechanism like this. And also this is the evaluation result of comparing proof of reputational intelligent reputation and proof of stake and proof of work for the distribution of frequency. And we have here leader and nodes evaluation. For leading zero, evaluation of consensus mechanism and transaction time in monopoly attack also has been evaluated. The third work is energy-aware proof of authority. This is a conventional. Previously, we have conventional blockchain consensus mechanism that are inhibition for wireless sensor network and our IoT and low resource environment. We have key challenges such as high energy consumption, high computational complexity, and latency and scalability limitation for this. So this is being designed specifically for clustered wireless sensor network environment and lightweight blockchain system, in which we have this connectivity for wireless sensor network. We have the base station, the sensor node, the cluster head, and the user here connected through the internet. And we conducted a proposed method to select a leader, which is called dynamic leader selection mechanism, which replaces static round robin selection with energy-aware dynamic scheduling, appoint the node with the highest current battery level, and also mitigate the premature node exhaustion through real-time energy monitoring, promote uniform energy depletion to extend the total network lifetime, and facilitate efficient block mining through battery-conscious task allocation. And here also we propose the multi-level blockchain architecture to have a two-tier hierarchical blockchain framework and independent local blockchain enable parallel data processing here to be enabled in this multi-level blockchain architecture to ensure that concurrent inter-cluster operation accelerate the block production here. So the result and evaluation is that we have energy-aware proof of authority. We evaluated the network lifetime enhancement through different heterogeneous node of wireless sensor network simulation, and also evaluated the improved proof of authority. And we see that using energy-aware proof of authority, we can have this around for the initial node failure delayed in improving the network lifetime. So actually, it achieved approximately 8 to 10% longer network lifetime, and real-time battery-aware task allocation enables balanced energy consumption and prevents premature node exhaustion. And also, we have evaluating the throughput evaluation for this total block created under different number of clusters, and also evaluated the hierarchical architecture in this leader selection mechanism. So if we compare our work in MPT, POIR, the proof of intelligent authority, the energy-aware proof of authority, we can compare it in different dimensions. For data structure, for example, we from the state-of-the-art of Merkle Patricia 3 to MS-MPT, we can have some key advancement, which is more scalable at some scale. And also for the consensus and fairness, for the proof of intelligent reputation, compared to proof of work and proof of stake and decentralized proof of stake, we have the key advancement of using AI, which is LSTM reputation, and the standard deviation being evaluated also better. And also consensus and energy, we have the contribution improving the static round robin in proof of authority to have an energy-aware leader selection, and also improvement of network lifetime. And also for sustainability, the implementation are based on different problems we found in sustainability for general purpose blockchain, and also ensuring that SDGs metric embedded into the design in our system design and engineering. Okay, so these are some conclusions that we have shown. However, I should have shown some work later, but this is for the last three consensus-based core research contribution. The MSMP is high-performance blockchain data structure. It enables efficient multi-state queries, improves scalability for IoT and healthcare system being implemented there. And also for proof of intelligent reputation, we have AI-driven consensus using short-term memory-based reputation analysis, enhanced fairness and decentralization, reduce validator monopolization. And also energy-aware proof of authority, it has improved the consensus for wireless sensor network, extend the network lifetime, and also support scalable and lightweight blockchain deployment being implemented into different SDGs problem and solve it in the work. The second part of the work is to see how blockchain has been implemented in real world problems and its impact to achieve sustainable development mechanism for different things. such as this work on blockchain, stakeholder perception on peer-to-peer energy trading model using blockchain technology in Indonesia. It is a work done by one of my students also, blockchain-based peer-to-peer energy trading model implemented using Hyperledger Fabric. Previously, the one that we talked before was generated from our code. Some of the work also conducted using Ethereum for the implementation. And this was done together in one team. So the system architecture is for community solar powered microgrid with components of solar panels, batteries, smart meters, and mobile trading application. This is real world implementation for community based solar panel usage for mini grid system. And this is the result of the evaluation of when the energy should be held and maintained and should be sold to other user to indicate long-term operational potential for this. And also, well, there is a lot of improvement, of course, before this can be really used to improve the condition of people in electricity needing area. So the second one is we also implement this in IEV charging infrastructure, electric vehicle charging infrastructure, in which we redesign charging system for car, for electric mobile vehicle. Using Hyperledger Fabric, blockchain smart contracts, middleware, API integration, we address security, transparency, transaction integrity, and scalable EV charging infrastructure, such as this, in which we have blockchain-based charge-in workflow, which shows complete EV charging transaction from charging session communication, middleware, API integration, and Hyperledger Fabric interaction. And also here we have the blockchain network structure. For this, we have peer nodes ordering service, which is we use the electricity from Indonesian state government electric company called PLN. And smart contracts using chain code in Hyperledger, channel for secure transaction, membership service provider, architecture benefit, and also secure decentralized transaction management here being used. And we found that we can ensure high data integrity and transparency, controlled access using blockchain channels, and support scalable EV charging ecosystem to be enlarged later on, to be scalable later on. And these are the result of the testing for the Hyperledger Fabric for on-chain and off-chain MongoDB, write and read mechanism and metric. We have this result of performance evaluation, and also we do the prototype implementation. We demonstrate real prototype implementation using Code Igniter and PHP integrated with Hyperledger Fabric and middleware-based blockchain communication. Here we have also evaluated the third work, which is on blockchain-based building information modeling for construction transparency. We know that eventually we need to have the information on all buildings, eventually for 7 dimension of data that is provided from electricity, thermal comfort, the mechanism to evaluate the vision, everything, the 4th dimension of the cost and all the architecture. So that is why we need to have something that is going to be embedded into the information of the building. And eventually we think that blockchain-based building information modeling is necessary to be conducted, to be provided in the future. And we actually at the moment, at that time, compare the PBFT and decentralized PBFT approach for consensus for this. This is the thing, knowing that from building owner to contractor to the user, a facility manager, and until the life cycle assessment of the building, we need to have a blockchain that being used so that the data ledger is distributed ledger technology enables the verification and record that should be immutable and transparent evaluation for this. And we use Hyperledger Composer for this. The fourth contribution, for example, in SDGs is in e-waste management with blockchain. Here we have electronic waste management using Hyperledger Fabric, and also for payroll and attendance system, news verification with Ethereum and interplanetary file system for storing the data, and also blockchain-based electronic management record. Electronic medical record. For this, we have different approach to ensure that the implementation in Ethereum, integrating on-chain and blockchain and on-chain and off-chain data, such as in IPFS for decentralized storage, smart contract for access control, and using a mechanism of rating reward mechanism that incentivize hospital to share data, improving institutional integration and patient service quality. In game also, in different things, we can ensure things like implementation of blockchain in multiplayer game cheat detection. For example, we have an existing anti-cheat system that can really hold the data, ensure that the both side of the gamer will not exploit the use of lack of switching or using DDoS attack or a different mechanism to make other participants to lose the competition. So we propose a blockchain-based cheat detection system using Ethereum smart contract to store core gameplay data immutable, that is immutable, and ensuring consistency, traceability, and resistance to manipulation. Well, when we are talking about challenges, we know that during the last year, we found that many, even though previously we know that many companies are using it, but we know that the cost for implementing blockchain is still expensive compared to the regular normal database. Also, at the moment, when we are using for financial sector, such as cryptocurrency, there is no regulation that is really being deployed. So regulatory uncertainty, blockchain deployments operate in legal gray areas where data sovereignty and digital accountability frameworks remain underdeveloped at the moment. So it's a big open space area for everyone to contribute, but we know that we need to have a mechanism to ensure that efficient, ethical, fair, transparent, accountable, and also safe and secure infrastructure should be used by everyone, should be implemented also to ensure that collaborative learning and continuous learning for everyone to use and to deploy technology is being done everywhere in the world. So we know that also the challenge is that we have digital infrastructure gaps. So we rely on stable internet and cloud services risk, excluding rural and underserved communities at the moment. So this is urgently our target to provide a digital infrastructure that can be used so that 1 hour of work of someone's work in Jakarta really means the same as 1 hour of someone's work hour in Colmar, for example, in France. So human capacity constraint is that we have long-term operation requires ethical and contextual competencies, creating sustainability risk beyond initial deployment. And at the moment, many institutions are still resistant to deploy blockchain because maybe seen as disruptive by centralized authorities, requiring stakeholder and engagement, requiring change management beyond technical implementation. And also at the moment, the SDGs impact measurement for quantifying technology's actual contribution to SDGs progress remains methodologically complex due to overlapping factors and multidimensional indicators. So these are the strategic implementation recommendation. We should mainstream the SDGs alignment from inception, develop collaborative governance framework, invest in infrastructure and capacity building, foster transdisciplinary research cluster, establish a unified mechanical and electrical framework to develop indicators that capture trust, participation, resilience, and fair standards to be developed and different metrics to develop that. So this is the work that we have done, and also the SDGs mapping contribution to reduce inequalities, create sustainable cities and communities, ensuring responsible consumption of energy, climate action and mitigation, and also industry and innovation, as well as energy and climate change mitigation. So these are going to be always needing an interdisciplinary work together, integrated collaboration across computer engineering, AI and data science, sustainability science, digital governance, ethics and public policy, and large-scale mission-driven blockchain ecosystem. So in the last 5 minutes, I will talk about the future research direction. Some of these are still very hard, but we just would like to show that something like responsible AI, energy-aware mechanism, such as different mechanism to ensure that blockchain can be used to implement blockchain into the real life, could be implemented, but this is something that may be something to write for the research, but also some implementation that needed a lot of collaboration. But well, we just would write about it. But this, for example, cooperative for the next generation consensus protocol, we could build a cooperative puzzle solving and non-zero sum validation. Also, privacy preserving validation using zero knowledge proof, ZKP integration into consensus layer will enable validator to confirm a transaction legitimacy without revealing the underlying sensitive data. For example, when we have medical data that should not be known by the intermediary, we have the zero knowledge of proof, privacy preserving validation. And also autonomic governance through meta consensus mechanism, in which we have on-chain meta protocols to allow a network to vote and to adjust its own parameters in real time. Lately, we also been working on this DAO, distributed autonomous organization implementation, to ensure that the mechanism for getting some votes from everyone will be conducted, can be implemented, and there is a mechanism in DAO in the latest decentralized architecture that we have now called decentralized autonomous organization architecture. So also for future direction in climate accountability and ESG tracking, we can eventually have, many people now are talking about this, verifiable climate finance registries and carbon markets. So we have to ensure that everyone look into the carbon trading and carbon footprint impact to our world or to our earth. That's why we can use smart contract as the fourth generation of a blockchain to record its transaction transparently and bind it into pre-approved mitigation action. And also for the second one, we could implement decentralized environmental monitoring with IoT sensor, coupling blockchain with real-time IoT sensor to create tamper-evident monitoring of air, water, and biodiversity to support community-led oversight where institutional presence is limited. So this is something that later I can show. But we also have the alignment. We should align with it's only another 4 years to achieve Sustainable Development Goals agenda. We never know. Even during the last 2 years, we have been quite going away just directly from our direction because of some problems, war, and we still need to implement some climate action, ensuring responsible consumption and production, and also use the natural resources wisely, and also ensuring partnership for the goals to embed sustainability into the operating logic of digital infrastructure. For the third direction, which is creating federated and edge-integrated architecture, we can implement a federated framework for inter-organizational collaboration, blockchain-integrated federated learning for trustworthy AI, and also ultra-light nodes and cryptographic offloading at the edge. This is, for example, last semester we have ESP32 to verify this blockchain mechanism, and that is work to delegate some mechanism in implementing blockchain into our IT system. But we're talking about ultra louds and hashing mechanism, and that we need to think about the edge and the nodes itself. And also for the fourth future direction, I think it's too much, but this is just like designing auditable and correctable smart contracts, ensuring fairness in AI, enhanced consensus, and embedding privacy by design into architecture. And also for the evaluation framework, as I told you that last week, we announced the framework, which is called FTAPS SIC framework to evaluate ethics, fairness, transparency, accountability, privacy, safety, continuous learning, and collaboration by self-evaluation from for example, the institution, for example, university leaders, to ensure that they are aligned with the SDGs. But also, this is for providing electronic digital infrastructure that is looking into a STEM framework that is sustainable in the future. So we also should standardize social impact indicators, looking into life cycle assessment, such as previously I told you about building information modeling and energy profiling. And also for the sixth direction, in which scaling and piloting mission-driven use cases, we could look into how to scale the system for health regional system integration for health management, for example, or for example, launching a holistic smart village platform. But I know that it's very, very expensive to do at the moment still. And establishing an interdisciplinary blockchain living lab for producing prototypes, policy brief, toolkits, and skilled workforce capable of being a blockchain developer in the future. Okay, this is, for example, the DAO cooperative puzzle-solving blockchain for the first consensus, but I think the time for me for the 45 minutes is enough. I thank you very much for your attention for my presentation. Back to you, President Linda Mogdat. Thank you.
Thank you very much. So thank you for your presentation, which is well presented. And now we will move on the questions, and I will give the floor to the first reviewer as you give it in your manuscript. So please, Hassan Fouchal.
Thank you, Linda. Thank you for the presentation. Appreciate it. On time, a little bit delayed, but it's okay. So it was really impressive as a big work, various work on many things. And it's very, very well appreciated. Thank you. But we need to answer some questions. Are you ready to ask some questions? Are you ready about that or not? I don't hear
Hopefully. Yes.
Don't worry. So, you talked some in, I think, in the slide 7, you talked about, you worked on the energy efficiency. My question is, how is energy efficiency is, let's say, is handled in when blockchain is there? Because there is a kind of contradiction in slide 7. Yeah, here.
This slide 6 and slide.
Just the one after this one. Yeah.
Yes.
Yeah, here in January you said you worked on a kind of energy efficiency in your discussion. I wanted to have some high-level ideas about the idea of getting energy efficiency with blockchain, because in my mind this is still a little bit hard to align them.
Yes, thank you very much, Professor Hassan Foshal. Yes, energy is something that is a big problem in the implementation of blockchain technology. The problem is coming up with the implementation of proof of work, for example. It requires a lot of energy to run, for example, mining the Bitcoin, mining and getting the consensus of all users to accept that without intermediary in the middle, they can keep all the data. So at the moment, different approach is being used to do and to select the leader, from the proof of work to proof of authority and proof of stake. For example, we try to use the energy more efficiently. But the problem is here is that we to limit the way, for example, we move from proof of stake mechanism is that those that is winning to have the opportunity to control all the stake is that the one that already have the previous one, so the previous stake. So in this case, we try to make sure that the selection, the node selection, the leader selection in this mechanism is conducted efficiently to decrease the use of energy. That is why the new consensus mechanism, proof energy aware, proof of authority, proof of stake is to limit the usage of energy in ensuring those that gets the opportunity, the token will be those that is selected via the less energy required for that. For this case, for example, that is the work that we do for this mechanism for this, because the energy consumption can be designed specifically for different environments, such as wireless sensor network for light blockchain system. But in this case, the selection, the lower level mechanism, for example, in dynamic leader selection mechanism, previously we used round robin selection, but in this case we appoint the node with the highest current battery level as the round leader and mitigate premature node exhaustion through real-time energy monitoring. So in this case, is promote energy uniform energy depletion to extend the total network lifetime and facilitate efficient block mining here. So the way we we do the task allocation to look into how we can facilitate efficient block mining through storage, energy storage conscious task allocation. So this is an example of proof of authority energy aware leader selection mechanism that we introduced previously. I hope
but
that
in fact, you're talking about balancing the energy, not the efficiency, because at the end, the energy consumed will be the same. But you're just talking here how to balance the energy consumption, not really the efficiency, but because the efficiency is something which is in any case will be consumed. Are you agree with that or not? Because
yes,
what you explain here is just how to make it balanced.
true. It is energy aware that we call it to make it efficient. Still talking about usage here. So I agree with you that this is aware of the energy, but the balancing and improving it and how to find later on different way to reserve energy is necessary. I hope that.
Thank you.
Yes.
Also, I see that in slide 17, you have a kind of experimentation with only 20 nodes. I'm a bit surprised because when we want to validate any, let's say, here, your execution here, you only used 80 to analyze the effects of the various attacks, right?
Yes.
Yeah, but do you think that 20 is quite enough to show the, let's say, the strength of your, let's say, of your proposal?
Yes. Okay. Thank you so much, Professor Foshal. Yes. In order to prove and to compare the proof of intelligent reputation, in which we have the mechanism to evaluate the reputation of each intelligent nodes here. The one shown here is to show that eventually from the first deployment, we come up into the stabilized distribution of frequency here, and up to 20 node, the result is almost getting into same balance here. But we also did check with the mechanism to evaluate this in larger scale. I hope you can refer to the paper if you would like to discuss it more. But because this is implemented in our own simulator, is not in it's quite limited, but we could compare it apple to apple with proof of stake and proof of work.
That's why I'm surprised, because it's in simulation. You can help yourself. You can go more than 20. If it was in real life, I would understand that 20 could be difficult to reach. But for simulation, what was the limitation to go more than 20?
Well, at that time, our computational power and also time for improvement, because this is the requirement to compare at that time. Actually, the node number, I think there are. I have to really ask the student who did this, but I know that it takes a lot of experiment and a long time of complex computing power necessary at that time. So we only show that here to make sure that this is clear, that it come up to the stable condition. The more you have, the more nodes you have, actually the distribution frequency of this monopoly attack evaluation is like this, in which we have, for example, node 1 to 4 is being used on proof of stake, 58% managed to control the majority of transaction processes, but for proof of work, 32%. and for the proof of intelligent reputation like this. This is to show this. So I will
Yeah,
check.
but what I'm saying, maybe you have until 20, you have this kind of convergence. But who knows if I'm going until 30, maybe there is a kind of non-convergence. We don't know, because that's what I'm saying. It's so small that the future, you cannot tell me that if I have 30 or 40 or 50 nodes, if the behavior is still the same. But anyway, that's the work. No comment about that. Okay.
Yes, we'll talk about it again here. Thank you.
I have maybe one, two other questions. I will stop. On slide 21, you had Linda. Do I have still some minutes to ask my two questions, or I have to stop?
Yes, you can, Hassan.
In slide 21, there is also one. Show it 21. Yes, about you saying 22. Yeah, here you tested on. Is it in simulation also? Yeah. Here.
Yeah, the simulation.
Yeah. And then, what is my impression is, when you use wireless sensor networks, the nodes are supposed to be light from computation, from memory, from energy, and so on. How is the idea to use the blockchain over wireless sensor networks? It's quite strange, because they're not supposed to have enough energy to be designed for implementing let's say, a blockchain system.
Thank you.
Do you understand what I mean?
Yes, actually, this one is our simulation, but last semester we actually use a microcontroller and some sensors to really do the deployment to ensure that the system, the IoT system, is secure. This is the idea on ensuring that the energy, the mechanism for the consensus, but for the implementation itself, in real implementation, currently we evaluated already. It is actually we can use blockchain technology to make sure that the good nature of blockchain can be used into the wireless sensor network and IoT system. And our network lifetime evaluation and also throughput evaluation also shows that. But I didn't have this in here yet. We haven't published the result yet. For that, but this is when we look into the idea of the energy-aware proof of authority consensus mechanism and check this on in 256 node heterogeneous wireless sensor network. We have achieved a longer network lifetime, and actually also the real-time battery-aware task allocation is becoming swapping energy consumption is happening, and from the figure of evaluation, we get that when we created when we have more cluster, the total block created also increase like this. So yeah, this is a simulation of the idea that being implemented in our network simulator, blockchain simulator, Prof. Foshal.
Okay, but in any way, I think you will be faced to this limitation, because blockchain that consumes and wireless network or IoT nodes, they are supposed to be light. They're not there to work with hard computation processes. Okay. And my last one is about, slide 23, about the POIR, AI-driven. And I was wondering, 23. No, it's not. Yeah, here. Your consensus is somehow in POIR is based on, let's say, a kind of prediction on AI processes, right?
Right.
So that means we're supposed to have the following. If we repeat in a blockchain process the same actions in the same environment, we're supposed to reach the same results. But here, using AI-driven consensus, are you sure to be always sure to get the consensus in the same result if you repeat the experimentation many times? Because I'm a little bit, let's say, confused about the use of AI-driven consensus for blockchain. Can you elaborate more, please, in few sentences?
Yes. Here, when we start to create our intelligent reputation proof of authority, proof of intelligent reputation consensus, we use AI based on the short-term memory to analyze the reputation previously there in our data set. So this is conducted by ensuring that intelligent reputation evaluation. Of course, it requires some energy also additional, but we found that it is quite efficient when we compare the one before. Here, we have the leader for proof of stake standard deviation is 0.73 for our POIR, but for proof of stake is this number 48. Yes, this is to introduce the use of AI evaluation in evaluating the previous data that we have, because we have some mechanism to improve the fairness in our newly introduced consensus mechanism, Prof. Hashan.
Okay. Thanks very much.
Thank you.
I will let the floor to the other colleagues. Thanks very much. Bye.
Thank you, Hassan. Thank you, Hassan. So I will give now the floor to the second reviewer. So please, Professor Ahmed Knight Sidi Mohsin.
Okay, thank you, Professor Mukdad. Thank you, Dr. Sari, for this good and clear presentation. First of all, I would like to highlight that your work demonstrates remarkable consistency and relevance, addressing both applied and fundamental challenges in the field of blockchain technologies. I remark also that through your contribution, you developed contribution on high-performance blockchain consensus mechanisms. You developed some application, of course, regarding sustainable development, and you are focused on the use of blockchain and information and communication technology to support the sustainable development goals. I would like also to highlight that I say that you have developed a coherent and impactful research agenda that combines technological innovation and with societal needs. Reading your reports, I would like also to highlight that and the significant volume of quality of your scientific production, which reflects your sustained commitment to research excellence. Also your supervision of many PhD and master students illustrates your dedication to monitoring the next generation of researchers and contributing to the development of academic talents. So, having highlighted these many points, I would like to ask you a few questions to further explore some aspects of your work and research vision. My first question was already asked by my colleague Hassan, is about the energy aware and proof of authority protocol. And my question is, what trade-off, if there is any, of course, were identified between energy efficiency, security, and decentralization and fault tolerance with evaluating proof of authority and energy aware against existing blockchain consensus mechanisms.
Yes. Could you repeat it again while I
So my question is about what trade-offs, if there is any, were identified between energy efficiency, security, decentralization, and fault tolerance when evaluating proof, authority, and energy aware against existing blockchain mechanisms.
Right. Thank you so much, Professor Ahmed Knight, for your comments. I would like to say that during our work in this energy aware proof of authority work, we try with the two problem, which the conventional blockchain consensus mechanism previously should we require them to be energy efficient. Decentralization should be there, and also should be fault tolerance, of course. During our implementation and introduction of leader selection mechanism to combat the high use of energy, the computational complexity and latency, we try to have a lightweight blockchain system in which this dynamic leader selection mechanism for selecting leader is being used. Previously, at that time, we haven't really used or do this in real testing environment. So we try to have this in lower level consensus mechanism to mitigate the problem in real-time energy monitoring and to ensure that we can facilitate block mining to do the task allocation among the nodes here. So maybe if you ask about the trade-off, I would say that at this moment, of course, because the real implementation has been conducted with one or not really a lot of IoT based system. I could not be seeing a lot, but this is the idea of mitigating the problem in real-time energy monitoring. I think that we have to do this trade-off evaluation in more detail later on when we do the implementation in real life. For example, I prepared the work on implementing this, like this governance in creating a consensus mechanism that is more on looking into this trade-off of different fault tolerance mechanism, for example, and decentralization. But I will look into that in more detail, the trade-off, Professor Knight, if it's possible. But this is the idea that was seen. And of course, it is the future work that is necessary to improve that energy-aware proof of authority work that we did before. So I will see that in more detail about this evaluation when we do more on more of IoT sensors and things.
Okay, thank you for your answer. And my second question about your developed applications and their deployments. Among all this blockchain-based application that you have worked on, which projects or which application have progressed beyond the prototype stage or simulation stage, and what evidence demonstrates their effectiveness, for example, in societal impact in real-world environments?
Thank you for the questions. Actually, when we did this habilitation, what I would like to report is to map that the problem, current state of the problem in the society with the things that we did before. Actually, some of this, as I show you, some, for example, the peer-to-peer energy trading was done and conducted because it was supported by an agency, but to scale that system into usable system used by the society, it is currently still being evaluated because it requires a lot of maintenance and requires a lot of education for the users also. In other way, also we know that actually blockchain requires a lot of energy to save and to keep the data. Even some companies are, after 3-4 years of implementing a way of tracing and creating traceable products from the initiation of products, for example, milk, to how we sell it in 24/7 in market, for example, in groceries. It is eventually they couldn't, when they compare the costs with the blockchain and the current costs with the normal database system, they prefer that. So this is still a question, still being asked. That is why not many people really move forward to implement blockchain for the problem of this. But at the same time, many companies also be implementing this in, for example, to ensure a decentralized system in which the governance participants of the events is being conducted, for example, in voting mechanism and other things, it's being implemented. So in our work, that if you see this example of charging infrastructure with electric vehicle charging infrastructure, we try to evaluate that to see how our national state electric company can control their charging system world national base, local and regional base electric vehicle charging system. It is being still in the condition in which we implement the blockchain system in and do the prototyping, and this is the prototyping mechanism to be built. However, to have a impactful effect for the user to be used in a large, really collaborate further, and I think they will choose always the cheapest mechanism to do this. That's why this is also something that we would like to see in the future. But because this is new and we develop a lot of, at the moment they develop a lot of electric vehicle charging system points, this is something that might be implemented. Also, for BEAM, we've been talking with some construction company. They requires a lot, a way to ensure that their 7-dimension data of a building could be saved. Now, at the moment, they are just using network, and we don't know the lifetime, the life cycle should be the life cycle of the data. Mechanism to preserve that is still being considered quite expensive to implement this blockchain BEAM. Also, for this is an example of also our prototype for e-waste management. Of course, this one is easily can be conducted. I think many companies already do this only for this tamper-proof human resource data management, for example. Okay, and this idea of ensuring that news verification, and we actually try to do different sort of applications using blockchain to serve as a storage for this. Yeah, at the moment, actually, it requires a lot of cooperation and integration of the work and the mechanism, and moving forward from the previous system that they have. But this is showing that blockchain technology can be used, as we can see already, in cryptocurrency, and the way we can distribute wealth without having to have the intermediary person in the middle. So it can be peer-to-peer mechanism in which people can send money and different digital asset, for example. So we think that for this, we need to have the capability to ensure that we evaluate the framework for the system. That is why even mechanism to ensure that the fairness, transparency of data, the accountability, privacy, safety, and security can be self-evaluated, and also implementing standards such as ISO 42001 in evaluating it. And this is the framework that we introduced last week, called Read Charter, way of evaluating electronic digital infrastructure development, the way we do the ensure that our data is being the test data, the training data should be evaluated. And this is the way we actually go further at the moment. As I told you that I also work on evaluating university performance in their sustainability achievement in 6 indicators, such as their waste management, water, and other infrastructure, to be able to ensure that sustainable infrastructure can be provided by an institution. I hope that answers.
Yes, good, perfect. I have another question about the ethical consideration.
Maybe excuse me, Ahmed, maybe the last one. Huh?
The last one, okay.
Yes,
the
please.
last one.
Thanks.
Okay.
Thanks.
So it's about the ethical consideration in this real world application, and the question is how do this blockchain application balance transparency, accountability with privacy, data protection in sensitive sectors such as healthcare, governance, misinformation management.
Right. Thank you so much. When we are talking about this digital infrastructure, this is the fact that we have, as I told you, tools should be measurable, auditable, comparable internationally, and not overly overburdensome to evaluate, but not only for blockchain technology. For example, we evaluate whether they have established the policy, AI and Digital Ethics Committee, and conduct ethical impact assessment, for example, such as AI registry, AI system registry in their institution or in their university or company, for example. This is the way related to other mechanism to evaluate this based on fairness, transparency, accountability, privacy, safety, and security, in which we have different questions and mechanism to evaluate whether they already have some documentation to prove that they have the evidence that they have assessed the framework, have the registry for each implementation and details of for that. So this is basically not only for blockchain based, because blockchain is basically only replacing the way we save data previously to ensure that the data is being transparent, immutable, and cannot be changed, and can ensure that everyone can do the peer-to-peer connections with it. So that is why to the future, we would like to see evaluation framework probably based on mechanism that we call responsible AI, because everything that we do now basically needs to also consider the use of artificial intelligence in all sectors. Thank you, Prof. Ahmed.
Okay, thank you very much.
Thank you, Ahmed. Now I give the floor to the third reviewer, Abdelmajid Bouabdallah. Abdelmajid.
Thank you, Linda. Thank you, dear Sarah. I would like to join my colleagues about what all they said about the quality of your presentation, very good presentation. And I really appreciate your document and your huge experience in terms of research, of management of research, of supervising all these results. My colleague gave all the details about that, so I confirm that I join him about what he said. I have just a few questions, more general questions, for which please give very short answer before Linda stop me. I would like to ask as much as questions possible.
Right.
So about your first contribution, where you propose MSMTP, what are the constraints if we want to integrate this solution in the existing blockchain with the new management of? Your solution, MSMTP, where you define the new data structure, all these things. I wonder how we can integrate this in the existing blockchain, or we have to use it in our private or own blockchain.
Thank you, Professor Abdelmajid, for your questions. Yes, when we introduce this multi-stake Merkle-Patricia tree data structure, we first learned about what Merkle-Patricia tree has and how the efficiency should be improved there, and also how we use account-based architecture here. So at the moment, we need to use this MSMPT in our own simulation. So enhance the conventional Merkle-Patricia tree by integrating a linked list structure for lightweight blockchain system and efficient multi-query processing. And the key innovation is that the leaf nodes here store a single final value. So in traditional one, but in here, The leaf nodes point to linked lists containing some account balance, total income, for example, expenditure, and historical states of the data. This means that we need to use our own simulator for this implementation. But of course, once we already established this, it could be implemented in other tools and platform if it's demonstrate better scalability and high efficiency system. So yeah, we did implement it in simulator, but not yet in openly used tools and platform for blockchain.
Okay,
Thank you for the question.
Just the idea, if we, I don't ask if you did implement it or not, if it is doable on the existing. This is what the question is very general. I don't need the proof if it's done or not. No, yes. Let me go to another question. It's a very good answer. I understand. The other general question, still on this contribution, when you introduce a new list, chain list, do you introduce some new vulnerabilities? Did you look on that or not? Since you have modified the structure, does this situation, your structure, induce new vulnerabilities because you are working on blockchain to secure, highly secure architecture?
Yes, thank you very much. No, at that time, we only look into this for validation. It is limited into this performance comparison. But other vulnerabilities which might have come, we also mentioned that in the future work. So a lot of future work being generated at that time, but we always try to make sure that the governance of the data structure deals towards ensuring that the new consensus mechanism that we introduce in the data structure will help to build a adaptive and resilient system to ensure that the usage of the framework, blockchain framework, is suitable and useful, knowing that we can have a different approach to this new data structure that we implemented. Yeah, vulnerabilities that we can say that maybe it requires a lot of introduction and some work together to integrate that into a new system. Yes.
Okay, thank you. I have another question about related to the POR. About the reputation, when you use the reputation, do you think that the old nodes who has good reputation will have a more advantage than newer who has low reputation in your system?
When we are talking about the intelligent reputation,
yeah, with the intelligent reputation, yeah.
Yes.
The old nodes who have good reputation, they are in the system since a long time. Do you think that they will have more advantage than the new one who just come in the system and they have very low reputation? Maybe they will be disadvantaged, no?
Yes, I think they will have a big advantage if they have a longer lifetime, and that will bring them towards more stakes to have the opportunity. So yes, old nodes will do have the opportunity for that.
Okay, so you don't have solution to manage to give more chances for newer nodes. Or they have a future research direction, maybe.
Yes, yeah, we did that. Think about that. Yes.
Okay. Now I go to the energy aware proof of authority. I have just one or two questions. Since your solution is
one question, Abdelmajid, please.
Sorry?
One question, please, Abdelmajid.
One. Okay.
Yes, please.
Related to this solution, since your solution is based on the cluster head, my colleague, I have already asked the question related to energy. I will not come back to this question. But related to the single point of failure, do you think how you manage this problem? because your solution is based on the cluster head.
Yes, single point of failure and fault tolerance is something that we consider before. We did try to improve that. I'm not sure if it's being shown here, but yes, we need to ensure that the system will not go into single point of failure, and there should be mechanism to combat that problem. So yes, here, for example, this architecture. Yes, but yeah, I think the mechanism is being done in the when the leader selection is being conducted. So yeah, that's what I could say now at the moment.
Okay.
But we will see into this fault tolerance more detail later. I think we wrote some.
Thank you again for your very good work and presentation.
Thank you, Abdelmajid. Okay, so now maybe Pascal Laurence, as the supervisor, if you have some question of some comments.
Yeah, not many questions, not many comments, but only maybe one question. For your next PhD, what will be the title of your next subject you will propose for your future PhD?
Yes, thank you very much, Prof. Pascal. I think just now I'm thinking about creating this responsible mechanism to responsible AI climate action engine, in which it's a larger evaluation of AI-driven decision intelligence, whether we can use blockchain or not. But this is something that I would like to embed in the future, how responsible AI governance layer can be induced into this climate action mitigation solution. That is, but it depends on the possibility and the wish of my PhD students, if they would like to go to a stunting problem, mental health problem that is being the problem of current generation. I'm open for that, because that is all related to well-being and also SDGs, meaning that every solution that we created with technology should look into the solution that can be used to improve the quality of life of people in the world. So actually, whenever they started a new problem, a new PhD endeavor, PhD journey with me, we are all open, but we are trying to implement and contribute to the knowledge, the improvement of knowledge and technology that we have, the current state-of-the-art one. And that is why actually that we do. But maybe if they would like to do that, fine, but that requires a lot of collaboration and also infrastructure and support also. So we are grateful that currently we still can contribute to the world, even though it's very limited fundings and opportunities, but as you know that with the collaboration we can hopefully work together to show that we can implement technology to the betterment of life of people in the world. Thank you.
Thank you, Pascal. So you had many questions. I finished only with one. So if you can identify one main limitation of your contribution, what is this limitation and how you can address it in your future research?
Thank you, Professor Linda Mokdat. The limitation that we face during our research is that the state-of-the-art contribution that we need to provide is quite high. We started with something that always change. And previously, I work with protocol engineering, and then in the world, in our funding mechanism, in our research, we are required to look into the solution to the problems, the real problems in society. As you can see that some consensus mechanism that we introduce will be just a small part of the system that is being shown or provided to the community. That is why we sometimes feel like it's moving up very fast. Like now, a lot of agentic AI solution could provide all the solutions. That is the limitation on the implementation itself. Once we do the real world implementation, is not as that good result as it is in the small scale or fundamental contribution to the world of knowledge. So I think the limitation is that at the moment that we have the always challenging mechanism and challenging research gap that we need to overcome. Yeah.
Thank you very much. So thank you for all of our committee. And now we are going to deliberate. So please go to the link for the deliberation. Okay, everybody has received the link?
Yes.
Yes.
Everybody.
Yes.
Okay, thanks. Okay.
Bye.
On se déconnecte. Okay.
Up. I don't hear no one.
Yes, I hear you, Hassan.
Only me, but no one is speaking, right?
No.
They are muted.
Not reached yet. Okay, okay.
You're here.
We're waiting for Linda.
Maybe she left for the lunch.
It's here.
I will send her back the link.
Oh, c'est bon, je vois là. C'est bon?
Okay. Welcome.
Okay. So the jury has deliberated, and we have some comments. So Mrs. Riri Fitri-Sari, the committee have said that you have clearly and well presented your academic background and your scientific work for developing blockchain technology for sustainable development goal and digital government. Your research covers a large range of topics, and you make important scientific contribution. You had also you had a lot of questions, and your answers demonstrate your excellent knowledge of your field and the clear vision of your current and future research challenges. Also, the jury highlights the originality and the consistency of your research, as well for scientific and societal impact. The jury is fully confident on your ability to supervise PhD students, to develop ambitious research program, and to take on research leadership responsibility. For all these reasons, the jury awards you de habilité à diriger les recherches from the University of Haute-Alsace. Congratulations.
Congratulations.
Thank you very much.
Congratulations.
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 Thank you, Prof. Linda Mokdad, Prof. Ahmed Naid, for Abdelmajid Bob Abdallah, and Prof. Hussein Foshal, and especially to Prof. Pascal Laurent, who has encouraged me to go through this habilitation from like 10 years ago, but I have the opportunity just now to do this, and I'm very happy that I can be presenting the work in front of all of you, and I hope that the future work will be better and will be beneficial for the society. Once again, thank you very much for your feedback and insightful comments, and also the paperwork that I have received. Thank you so much. I really appreciate this. Thank you.
Congratulations again.
You. Congratulations again.
Good luck.
Congratulations.
And congratulations. Bye-bye.
Thank you. Hope to meet you in the future.
For all for participating to this PhD, I'm happy that everybody can find time to participate. Thank you.
Okay, and thank you, Pascal, for the invitation.
It was our pleasure.
Dear
Thank you very
colleagues,
much.
see you again.
Thank you
Bye-bye.
very much, and I'll hope to see you in the future.
Bye. See you
Bye.
another time.
Bye-bye. Have a nice day.
Bye.
Bon appétit.
Bon
Merci.
appétit.
À vous tous.
À bientôt.
À bientôt.
Ciao.
Portez-vous bien.
Au revoir.
Merci toi aussi.
Merci.
Thank you, Professor.